Hello students, today's lesson is on solving rational equations. Equations, as you will recall, have an equal to sign in them. Solving means solving for the variable. That means you find out that value of x when you plug in here, and then you add these two terms. They should add up to 4 in this case. And rational, we have already discussed anything that can be written in the p by q form where q is not equal to 0. So this is a rational expression, x by 3, 2 by 5 is a rational number, and 4 can be written as 4 by 1, which is also rational. So how do you go about doing that? The idea is to get rid of this denominator. There is 3 here and there is 5 here. How do we do that? By multiplying both sides by the least common denominator. Why least common denominator? Because both these numbers will go into that denominator, so you can get rid of them. Okay, so how do we, in last 2 weeks, you have been working on, forming a least common denominator. So we're going to repeat the same process here. Here, Miss Andrews has put together some nice questions for you to practice and get the concepts right on solving rational equations. So step 1, write down all the denominators in a completely factored form. The numbers as the product of prime factors and rest of the expression as a product of the linear factors. So let's see. What are the denominators here? The denominators here are 3 and 5. So I'm going to copy them down here. Step 1 and 2 is write down the denominators 3 and 5. And write them as a product of the, so there is no variable here, no expression, so these are the only numbers. I have to write them as a product of the prime factors. So if you recall, prime numbers 2, 3, 5, 7, 11 and so on. 3 is a prime number, 5 is a prime number, so I don't have to do anything further. So I can just write down 3 and I can write down 5 and I can multiply both of them, and the answer is 15. So what is my, this takes care of my step 1 and 2, that write down the denominators as product of prime factors and linear factors, and then find the least common denominator, which is the LCD. Fine. Then the next step is step 3, multiply both the left hand side and the right hand side of the equation with the LCD to get rid of any denominator. So that is the main aim, getting rid of the denominator. So how do you do that? First thing you're going to do is always put the left hand side in parentheses and right hand side. So parentheses come in really handy when you have more than one terms, but even if there is one term, it's okay. You can still put it in parentheses. There's no downside to it. So once you put them in parentheses, the left hand side, the right hand side, you multiply them with the least common denominator, which is 15. Okay, so now this 15 is multiplied by 1 by 3x is distributed here because there are two terms. So you're going to multiply it by 1 by 3x, and then you're also going to multiply it by 2 by 5, right? So here separately it's shown 15 multiplied by 1 by 3x. So you can multiply the numerator with the numerator. The denominator is 1 here, say. The denominator with the denominator. So x is also in the numerator. So 15 times 1 is 15 times x is 15x and divided by 3. And then you can simplify the ratio of the numbers. 3 goes into 15 5 times. So you get your 5x here. You could have cancelled this even before, simplified it. 3 goes into 15 5 times, and 5 times 1 is 5 times x is 5x, and there's nothing in the denominator, so there is 1 and you don't have to put that. Similarly, you go to simplify the next term. 15 times 2 over 5. 15 times 2 over 5. So 5 goes into 15 3 times. You can do 3 times 2 is 6, or you can multiply 15 times 2 is 30, and then you can simplify the ratio. 5 goes into 36 times and you get your 6. Okay, let's talk about the one on the right hand side of the equal to sign. 15 times 4 is a 60. So now I'm going to replace this 15 times 1 by 3x, that was 5x, so 5x. Then you have your plus sign in between, don't forget to copy it down. So you have your plus sign in between, and then you have 15 times 2 by 5. 15 times 2 by 5, it came out to be 6. So you have your 6 here. Equal to sign, copy it down, and then 15 times 4 was 60, so you copy down the 60. Now it's a simple job. It is a linear equation. You are well acquainted with how to solve linear equations. First, you get rid of something which is added or subtracted to the x term. So this is the x term. First, get rid of the positive 6 by the inverse operation. If 6 is added, you subtract 6 on both sides and cancel it. That is the idea. Get rid of everything next to x one by one. 60 minus 6 is a 54. And then you are left with a 5x equals 54. Again, use the inverse operation. 5 is multiplied. You are going to now divide by 5. So 5 doesn't go into 54, so you don't have to simplify it any further. So you can just write the answer as a improper fraction. So it's 54 divided by 5. Okay, let's take up another example. Example number 2. So let's go step by step. First step, identify the denominators. There are 3 denominators here, so I'm going to write the denominators. So they are x, and then they are 3, and then x. Okay. Now, least common denominator, if you recall, you're going to take step by step. So the x. In the second denominator, there is no x, but in the third denominator, there is an x. So you can write this, x only one time. So this x and this x is taken care of by this x. And then there is nothing else left but 3. So I'm going to copy that down. So remember, if x or any factor is also present in any other denominator as a factor, you just write it one time. Okay. Now you multiply x with 3, it becomes a 3x. So this is your least common denominator. What was the next step? Next step was to actually, there's a mini step in between, to put parentheses across your left hand side and the right hand side of the equation, and then multiply it with the least common denominator, that was 3x, on both sides. Now, wherever there are 2 terms, you need to multiply, distribute this LCD over both those terms. And when you do that, as it is shown over here on the right hand side, 3x multiplied by 5 divided by x, 5 divided by x. You could have just cancelled this x with x, and you get 3 times 5 is 15. But if you want to just multiply the numerator with the numerator, 3 times 5 is 15, and you have an x here, you keep it here, and then you have an x in the denominator. Now you cancel the x with the x, and you get a 15. Either ways, I mean, you can do it any of the 2 ways. Similarly, when you multiply your 3x with 1 by 3, 3x with 1 by 3, you can cancel this 3 with 3 and get x as an answer, or you can multiply 3x times 1 is 3x and divide it by 3. So 3 and 3 get cancelled here, 3 and 3 get cancelled here, and you get x, right? And the third one is the right hand side of the equation, 3x times 1 over x. 3x times 1 over x, x gets cancelled with x and you get a 3, or 3x times 1 is a 3x, then divided by x, so x gets cancelled with x, and that is a 3. So now I'm going to replace this 3x times 5 by x with 15 that we got here. 3x, and then copy down the negative, the minus sign here, copy down the minus sign. 3x times 1 by 3 we found out is equal to x, and then the right hand side was equal to 3. Now again, it's a simple linear equation that you need to solve for x. So now look at the term which is added or subtracted to the x term, so which is 15. It's a positive 15. To get rid of that, inverse operation, subtract 15 from both sides, and your 15 gets cancelled with a negative 15. And here when you do 3 minus 15, it's a negative 12. And x comes down as a negative x comes down here. Now you want to get rid of this negative. So negative x can be written as a negative 1x. So negative 1x, inverse operation, negative 1x is multiplied, negative 1 is multiplied with x. So in order to get rid of that, you divide by negative 1 on both sides. And negative 1 divided by negative 1, they get cancelled. Okay, so you're left with x on the left hand side, and on the right hand side, negative 12 divided by negative 1, you know, is equal to 12. So that is your answer. Okay, let's go to another example now. Example 3. Okay, so you have, let's identify the denominators, 8 and 4. So the denominators are 8 and 4. Right. So 2, 3, 5, 7, 11, and so on. These are the prime numbers. 8 is not prime and 4 is not prime. So I'm going to use a prime factorization method to find the prime factors. So the lowest prime number that goes into 8 is 2 times 4, and then further 2 and 2. All three of them are prime. So 8 as a product of prime factors is 2 times 2 times 2. So this is the prime factorization of 8. Similarly, the prime factorization of 4 is 2 times 2. Now let's write the least common denominator. So you have, let's start with the first factor, 2. Is there a 2 present as a factor of the other denominator? Yes. So these two 2's come down as 1. Let's go to the next 2. This 2 is this is a 2, and then there is another 2 present. So these two 2's also come down as 1. What is left? 1, 2 that you copy down. So 2 times 2 times 2, 8 is your least common denominator. Next step again, parentheses, parentheses, multiply your 8 to the left hand side of the equation and 8 to the right hand side, and then you can see here, let's simplify this. 8 in the numerator because it's a factor. You can cancel a factor with a factor, not a term with a term. So 8 is a factor, so you can cancel them and you will get x plus 2. Similarly, here 8 times 3 by 4, and you can multiply the numerator with the numerator, becomes a 24, and the denominator was 4 times 1 is a 4. 4 goes into 24 6 times, and you get your 6 here. Now you replace this with x plus 2 on the left hand side, x plus 2, and the simplified 8 times 3 by 4 became 6, so you replace it. After that, you know what to do, how to solve for x in a linear equation. Get rid of the term which is added or subtracted to the x term first. So this is 2, you're going to subtract 2 from both sides, and you will get x on the left hand side. 6 minus 2 is a 4, and x plus 4 is an answer. Okay, I'm going to take up some more examples in the next video. I hope you understood the step-by-step process of how to solve a rational equation, and with the further examples, I'm sure you'll feel better about the concept. Thank you.